Hello friends, welcome back to the bench. Our patient today is this DVD player that you install in your car. This drops here, the nice 10-inch screen, right? And you put DVD over here. You can also put USB stick or an SD card. There's some AV2 in, so you can probably connect the other device to it and use it as a display. What happened to it? Our friend from Joy of Fixing channel installed it in his car for the kids and used it 3 times, I think 2-3 times, and it went dead, right? It doesn't turn on, nothing's happening. So he sent it back to the to the distributor and they replaced it. He got the replacement, he used it 3 or 4 times and it went dead in the same way. But the distributor will not replace it anymore because they discontinued this device. And I suspect they discontinued this device because it happens more often. Likely more customers suffered this fate. So let's see what is wrong. I obviously already diagnosed it. I know what's wrong with it, but let's do a little deeper dive. So the board is already detached. There's some built-in speakers, which is kind of a nice touch. 2 speakers built in, 8 ohm, 2 watt. When we connect power to it and turn it on, it is grabbing 0.6 watts and it doesn't, yeah, you can barely see it, but the on button and /stop button lights up. So there is a backlight on the on button, right? But when you press the button, oh, you can see it better from this side. You see that lighting up right here. When you press the on button or hold it or press it, nothing happens, right? So what is wrong? Let's flip the board without disconnecting, and immediately we see that we have power supplies over here because the device will be powered by 5 volts and likely 3.3, maybe 1.8, because there's a lot of electronics here. Like this one, if I recognize it correctly, this is RAM chip, so likely 1.8 to 2.5 volts that this requires, right? We have some larger CPU, or maybe this is the decoder and decoder, hardware decoder for the DVD, and we have some large CPU over here, which actually this is probably the encoder for the display, because this is the display connector. So this is likely what encodes our image for the screen. This is likely our heart. That probably also decodes the, because it's like close to the DVD connector. This goes to the DVD player, right? So most likely we receive the signal directly here. It connects to the memory and it sends the data to this chip, which in turn sends it to the display and to the speakers. So for all that to work, our power supply needs to work correctly, right? And we have 2 power supplies here. And you should immediately see the problem without even using the multimeter. Can you see the problem? This chip, as you can see, exploded. and we have two of these chips over here. Coils right next to them, right? So this is what produces voltages. So perhaps this is 5 volts, this is 3.3 or 2.5, 2.1, whatever, 1.8 maybe. What is this chip? Good question. The chip in question is AP2953A, which is basically, in this case, used as a step-down converter. This is typical application, which is what we see on the board. Roughly, I didn't check the components around it, but this is roughly what we see. So recommended, this is for 3.3 volts, 3 amps, right? I expect that we control the voltage by R2 resistor. This is the voltage divider over here on the feedback, and both the R1 and R2 dictate what the output voltage is. So we would have to measure it and calculate what the voltage what the voltage should be on the output. And it has it just connects to the choke, on which we generate desired voltage. We have feedback through 10 nano cap, and that's it. Enable pin, input voltage, feedback, comparator, ground. A very simple chip, very simple application. Now internals of that chip is roughly this. So we can see on the output we have half-H bridge, which allows us to push energy into the coil and receive energy from the coil. And that's pretty much it. Nothing too interesting over here. We know that it works on either 150 or 370 kilohertz, which doesn't really matter to us. What matters is that we know that we have a current sense circuit, current sense amplifier, so I expect that it shuts down when the current goes too high. Well, that would be our expectation, but what would cause this issue, right? Why would it explode? Normally, when I see those, that's usually when the voltage, input voltage, was too high and it just basically broke it. The other possibility, perhaps, in some cases of some devices, is when the current is too high and there's no current sensing or no current limiting resistor, and it just, I don't know, it catches short and heats up so much that the transistor inside just explodes, exploding the package. Now let's check the pin out. So our first pin is bootstrap, second is input voltage, and the third one is our switching output, right? These are the 3 pins that we're interested in. So bootstrap, input, output going to the coil, right? So the pinout matches, so we know we have the right chip, which means the transistors are going to be located somewhere here by the pin. So it makes sense that it exploded here, because this is where all the power is going to be transmitted from. So now what we need to confirm is there a short between input and output? If there is, then there is no point in replacing this chip, because 12 volts went directly to the coil and to our logic, and it would not be feasible to be replacing those chips because there is some binary in them. They're unlikely to be off-the-shelf components. It's possible, but it's unlikely that there is no code, no binary in them, no custom code, right? So let's grab a multimeter and put it in resistance mode. Red probe to the input, black probe to the output, and we have 28K, 29, 30, and it's rising because the cap is charging. So no short, but I'm not sure it's supposed to be like that. But we have the exact same one over here, which seems to be correct, which seems to be, you know, not broken, at least not exploded. Let's see if this one says the same thing. No, this one says 8 megs, 7 megs. So we have mega ohms on this one, and we have, oh, now it says mega ohms. No, now it says 6K. Oh, sorry, yeah, 11K, 12K, as the cap is charging. So we can't really break it any further. So to confirm it, well, it's not going to be a confirmation per se, but one more measurement that we can make is connect the power, switch to voltages, turn on 0.6 watts. Right, if we had a short, then, you know, we would be grabbing a lot more current. So our input is going to be 12 volts roughly, and on our output we want to see 0. We see 1 millivolt. 1 millivolt. There is no short, so we know this is not shorted at the moment. But here's the potential problem, because we can replace this. Actually, since we have it on, let's check the output voltage of this one. 5 volts. Yeah. So this one will likely be lower, especially since our coil is slightly smaller than this one, or at least it appears to be smaller. Yeah, that's a 220, this is 470, so yeah, what is that, 22 mic and 47 mic, maybe. So this likely produces the voltage for our CPU, for our logic, because 5 volts is not going to be what supplies our logic. That's why we have the LED under the power button, because that requires 5 volts, but nothing happens when you press it, because when you press it, you basically either pull high or pull down one of the pins of the CPU, and then CPU turns on the device. Right? The device doesn't turn on because the CPU is not powered, because it should be powered by this. So at this point, the easiest solution, or the easiest diagnostic step, would be to replace this chip and see if that resolves the problem. Meaning, is the device turning on? But we have two question marks. Number one, did the logic behind the coil survive? Did we push a strong 12 volt? Did we push 12 volts to the logic? Because the chip will not explode like this unless there was a lot of power. Just consider how much kinetic energy is required to explode the package like that. So that must be proportional to the electrical power that we pushed into the chip. So either the short on the output, which actually we can test right now. Yeah, so we are shorted on the output. That's why, oh no, hang on. Yeah, dead short. So that's what killed it. It tried to produce power and it exploded because there was just too much power. I guess our current sensing circuit didn't do its job. So, what could be shorted? Well, let's inject, I'm gonna guess, actually I'm gonna start, since it's dead short, I'm gonna start with roughly 0.8 volts to inject and go from there. Because with dead short, 0.8 should show us which component is heating up. So let's prep everything and solder in the wire and inject some voltage, see what's shorted out here. Now I'm giving it a minute to cool down after soldering, because that might send me on a wild goose chase. I don't see anything. That means that whatever's shorted has a very wide surface area, very wide connection area. So the heat is distributed enough, it's not centered in one place that would register on the camera as a blob, as a you know, tiny, as a light, as a dot, but instead it's spreading around. So it could be this chip that has a heat sink on it. It's only the wire that is heating up here. So I could push a little bit more energy to reveal it, right? A little higher voltage. But at this point, I know it's not going to be a tiny transistor. It's not going to be a shorted cup, because we would see that. It's got to be something that is dissipating the heat. Alright, I disconnected everything from the board, almost everything, but enough that I'm certain the short is on the board, but the short is so wide somewhere that it does not register on the camera even when we push 4 watts, even 4.2 watts. And in either case, so this would be repairable if we could see the shorted component, and also depending on the component, because if it's the memory, actually RAM is replaceable, that's not a problem, but non-volatile memory or a CPU, that will not work. I mean, the replacement will not work. Plus, where do you get the replacement even? It's not like it comes with replacement parts. Yeah, unfortunately this is no fix. We do know what the problem is, but we don't know where the problem is. So this is electro trash at this point. Which is weird, why wouldn't the fuse react to this? Why wouldn't the fuse protect it? Right? That's what it's for. It could be that the chip failed first, started conducting 12 volts, which in turn caused a short on the other side. That is also a possibility. So it's hard to say what came first. Either short came first, which is kind of unusual, especially on the rail like this one, maybe 2 volts. It's relatively unusual for that rail, even if it catches short, to just, you know, cause an issue, cause the explosion of the control chip. It's very unusual. So I would expect that the chip failed first, which caused short, which sent 12 volts to where the 3 volts should be, or 2 volts, we don't know. We can calculate it, but at this point it's just pointless. But that's what I think happened. The chip doesn't, I don't see whether it has thermal protection. Let's see. Yeah, it has thermal shutdown. Yeah, at 160 degrees. So yeah, I don't think it's the short that caused this fault. I think this fault caused the short. And what caused this fault? Normally it is input voltage that is too high. But if we had too high input voltage, which is unusual because you use it on your car, right? Other devices are connected to it. You basically, the majority of times you just work kind of like from the battery, right? Obviously it's coming, the energy is coming from the alternator, but I wouldn't, if you had, so say this chip, what's the max voltage on it? 20 volts. So you would have to push 24 volts to it, probably at least 24 volts, and judging by how the chip is broken physically, that would have to be a lot higher a lot higher voltage. So say 40 volts to cause the breakage like this. Which means a lot of other things in your car would break. And since we have two exact same chips next to each other, they both would have been fried. It's only this one that got fried. So I'm thinking it was a lemon, all right, just plainly faulty chip. It happens, and that's what caused the issue. The other possibility, yeah, there is another possibility that the coil is faulty. We can't really measure that. I mean, we could, just using an oscilloscope, we can measure the inductance. We can measure its resistance, and from resistance and inductance we can calculate the reactance. So we can totally measure this coil, but what for? The rest of the board is fried, and it's fried. So the reason nothing shows up on the thermal camera is probably because multiple components are shorted, which is consistent with 12 volts getting into the 3.3 volt rail or 2.5 volt rail. Everything got shorted. That's why nothing is showing up on the camera, because everything is heating up slightly at the same time. Every single chip that was supplied from this rail. Kind of weird issue. Maybe, I don't know. Weird in the sense that this isn't the fault I was expecting. Sure, the short, yeah, shorted cap, maybe some transistor, something like that, and yeah, we would find it easily. It's unusual, and I think that's what happened. The chip was faulty, and it sent 12 volts to the rest of the board, and the rest of the board is electro trash now, which is too bad, because it's too bad because now our friend has a hole in his roof. But sorry, there's nothing I can do with this. It just suffered too much. All right, let's contact the customer, see what they want to do. And there is a DVD inside. If you want me to retrieve that DVD, I can look into that. There should be a little lever on one side over here that allows you to retrieve the DVD. usually, but not always. So in that case, we probably would have to disassemble the DVD to retrieve the disk. Alrighty, that'll do. Unfortunately no fix, but at least we got to see what's inside of a probably relatively cheap DVD player. And it's cheap for a reason, and they discontinued it probably for that reason. This is most likely. I wish I had the other one to see if it would be the exact same fault. And maybe it's the coil that they just yeah, because the data sheet says, what was the data sheet saying? The coil should be 10 microhenries. Here we have, if I read it correctly, we have over 20 microhenries. So twice as much, right? Which means twice as much energy, twice as much flyback, or twice as high flyback. So maybe this chip should not work with 22 mics, it should work with 10. And maybe that's the fault of this device. Could be. Could be. The manufacturer error. It happens. Alrighty, that'll do. Thank you guys very much for watching. I do appreciate you. And I shall see you in the next one. Probably today, because I also have few other things to fix. Take care, guys.